Good morning to everyone. Welcome to the session of Computer Architecture. Myself R. Narendran, working as Assistant Professor in Erode Sengundar Engineering College, Tudupadi. So coming to the basic properties of computer architecture, we have already seen in the basics. So what is computer architecture? So before entering into the session, we shall have a close gist of what is computer architecture. So the hardware and software components are united together in a computer. So how effectively they are working together and how effectively they are correlated together to form a basic operational concepts. So that forms the basics of this particular session. Okay. So coming to this session, this is all about basic operational concepts in computer architecture. Okay, so to perform any given task in an appropriate time or duration, a program is needed. So what is a program? A program is a group or collection of codings, so which makes way for computer to work in a proper way. The program consists of list of instructions. These instructions act as a instruction that are given to the computer to store in the memory to perform a particular task. So the individual instructions are brought together from the memory into a particular processor which can able to execute the specific operations. These operations can be of anything. For example, the operation can be of normal arithmetic operation or logical or any kind of bitwise operations. So any kind of operations can be carried out in this particular operational concepts. So the data must be stored and the stored data should be retrieved from that particular memory location. So this is the basics about the operational concepts. So for performing these kind of operational concepts, we have to segregate those kind of instructions into a separate one. First, the instruction is fetched into the memory and then into the processor. Okay, so the operand at a particular location, for example, I have specified here by mnemonics notation as LOCA. So these particular operands are fetched and added into the content of R0. R0 is nothing but the register. Okay, R0, R1, R2 are some kind of general purpose registers. They are used for storing and retrieving a particular type of data into the memory. So finally, the result of a particular data is stored in the particular register that we are specifying. Okay, here R0 is the register name that I have given. Okay, so consider this particular diagram. So it is a connection between the processor and the memory. So how the processor, that is the central processing unit, is correlating with the memory unit. Okay, this is a main diagram behind the computational task. Okay, so this specifies different kinds of registers and different kinds of memories. So first of all, we are seeing the concept called as main memory. So it is the CPU memory. So it forms the first part of any kind of memory. So next one is MAR. So memory address register. So PC is the program counter and IR is the instruction register. So these are all present in the CPU only, that is central processing unit. So by using these different kinds of register memories only, we can able to do the bit by bit allocation of different types of computations. Okay, so next one is MDR. So memory data register. So MDR is nothing but memory data register. In this register, so the data is processed. So next one is R0, R1, R2 followed by Rn-1. This is nothing but a general purpose register. So by using these general purpose registers, we can able to process bit by bit allocation of memory or bit by bit storage of a memory space or bit by bit retrieval of a particular data from a huge set of memory space from the CPU. So next one is the control unit and the memory arithmetic and logical unit. So MAR, PC, instruction register, MDR, R0, R1, R2 up to etc. These kind of general purpose registers, and control unit and arithmetic and logic unit. These are all mainly needed for interacting with the processor in terms of computation of different kinds of memory spaces. Okay, so this particular diagram is mainly meant for how the different types of data transmissions and address transmissions are carried out between the processor and the memory space. So memory can be of any kind of memory, not only the main memory. Okay, so here are the basic gist of what are the different types of registers that we have mentioned in that particular diagram. So the instruction register. So instruction register is nothing but it's a special kind of register that is used to hold the instruction that is currently being executed in a particular memory space. Okay, so there are many kinds of instructions that are being thoroughly given to a particular central processing unit. So in that, this particular instruction register plays a vital role in holding the instructions that are currently being executed. So next one is program counter. This program counter is nothing but it is a specialized kind of register that keeps track of execution of a program. That in simple words we can say that the program counter stores the next instruction to be executed. Suppose the instruction register is processing a particular type of data or holding a particular type of instruction that is currently being running, whereas the program counter will take care of the next instruction that is being executed in the next step. So these two are different types of registers. Okay, so next one is in order to process the better way of communication between the data and address and the control signals, we are going to make the different kinds of movement of communication by means of different kinds of registers. For example, MAR, MDR, we can consider this. So MAR is nothing but memory address register. So it is particularly meant for holding the address location that is to be accessed. Okay, so in the name itself it is specifying as MAR, that is memory address register. So it holds the address location that is to be accessed, whereas MDR is the memory data register. So in the name itself we can able to identify that it is particularly dealing with data. So the data can be of anything. It can be of image or it can be of any bit by bit allocation of data. So it will consider it as a data. So it contains the data that is to be written or that is to be read out from the particular address location. So that forms the part of MDR. So get clear with this. So first one is MAR. It is used for memory address register. So it is used for allocation or holding of address location of a particular data to be accessed. Whereas MDR is nothing but it contains the data that is to be written or that is to be retrieved or that is to be read out from the address location we are specifying. Okay. So next. So these two forms of registers are very useful in retrieving and writing of any particular data. Okay, so we are having different types of registers. Okay, so how these particular communication or connection is carried out between the processor and memory, we have to go through a set of instruction steps. Okay, so first one is the program will be in the memory in a particular device. So the instruction register will take care of the current instruction which is particularly in the movement. Okay, for example, I have initiated a particular type of mnemonic data. So in that particular case, the particular first instruction when it is being executed, it will be stored in the instruction register IR. Okay, so the next one, the next instruction, the second instruction to be executed will be saved in program counter. Okay, so the content of the program counter is then transferred to another kind of register called as memory address register. So we have already carried out two types of registers, memory address and memory data register. So in this particular type of register, we are dealing with the content of program counter that is to be transferred to memory address register. The read signal is sent to the memory. So and the first instruction is read out and the particular data will be stored into memory data register. So we are holding a particular data after particular instruction is being carried out, right? So so that particular data should be stored in memory address register. We are specifying it as MDR. So next, the content of the memory data register is to be transferred to instruction register because next instruction is going to be processed. right? So so next instruction is processed by program counter, whereas the current instruction is carried out by instruction register. So afterwards these type of loopings will be carried out throughout the whole set of instructions are being executed. So afterwards we are going to decode and execute that particular instruction. Okay, so for that purpose we are having a additional type of data called as register called as general purpose registers. Okay, so general purpose registers are nothing but we are naming it as R0, R1, R2 up to etc. we will be specifying. So these are generally used for basic storage and retrieval of data. Okay, so for efficient storage and retrieval we are using general purpose register. So afterwards this processed data will be stored in the arithmetic and logical unit. It will deal with whether the instruction we are going to process is arithmetic or logic. Okay, so based on that it will store the result back into the memory. So once this particular cycle is being executed, the next instruction will be executed simultaneously in the looping way. So next the same set of instructions will be carried out and the program counter will increment the particular next type of instruction, and the next instruction will go on until we are going to finish that particular data. Okay, so here is the set of operational steps that we are specifying. So first one is the memory the program resides in a particular memory. The program counter points to the particular instruction, first instruction. Okay, so next one is the program counter content is transferred to MAR, that is memory address register. Next the read signal or write signal is then being transferred and it is sent to the memory unit. So the read or write signal is then processed and loaded into which memory? So memory data register, that is MDR. Okay, this kind of register. Next the content of MDR. So we are to process that particular content, right? So that content of MDR is then transferred to instruction register. So we already know that instruction register is nothing but it holds the current instruction being executed. Okay, so next one is we are getting the opcode of a particular ALU. Okay, so for particular ALU being executed, that is ALU is arithmetic and logical unit. It will process which kind of data that is to be executed. Okay, which kind of operation it should perform, whether it is addition, subtraction, multiplication, movement of data, or some kind of data communication instruction or signal. So next the result will be stored, and when the particular set of instructions gets completed, it will point to the end of statement EOF. Otherwise it will move on to the program counter. The program counter checks whether next instruction is there or not. So if some next instruction is there, then the program counter will process the above set of steps continuously for next instructions. Okay, so up to this we have dealt with the connections between different types of process, that is connection between different types of registers in correlation with the processor and the main memory. Okay, so this is what all about the basic operational concepts that is being carried out in a particular computer architectural way. Okay, so additionally we have to see the one more point at finally. Okay, that is called as interrupt. So interrupt is a main thing behind every instruction to be executed. You have to notice that, for example, the normal execution of a program may be preempted. Suppose if some devices are in rush up of some task to be completed. For example, a normal process is going on. Suppose I have to interrupt that process to execute a more important and quicker way of another instruction that is to be executed at once. Okay, for example, I am going to process a particular data. Meanwhile, I am in need of printing a particular 10 pages. So I will stop that particular process and then I will move on to next process, that is called as I have to take the printout of 10 sheets or something. Okay, so meanwhile if I am taking that printout, I just make the current execution of instruction to be subtle. For example, I will make it to wait for a particular period of time until I complete the next task. Okay, so that is the normal execution of a current program must be interrupted. The devices arises a signal. That signal is called as interrupt. So there are different types of interrupts are there: interrupt 0, 1, 2, 3 up to etc., which specifies hardware interrupts, software interrupts, any kind of interrupts. Okay, so for handling these kind of interrupts, we are having a special kind of routine called as interrupt service routine. Okay, so the current system information backup or restore. Okay, so for this purpose also we are using interrupt as a signal. So interrupt is nothing but a process that is being interrupted, or that is being made to wait for a particular period of time until another important task needs to be completed. Okay, so in this class we have discussed the basic operational concepts and different types of registers and different types of communication that is handled between the processor and the memory. Okay, so we will see with the continuation of interrupt in the next class. Okay, until that, thank you for listening. We will see in the next session. Thank you.